This is Professor Sarter back for another 5 questions. We're working on question 16, I believe. Yes, question 16. And the directions on this say simplify 3 times the 5th root of 96. So we want to simplify this radical. It's the 5th root, so it might be a good idea for us to write down some perfect fifths. So 1 to the 5th is 1, 2 to the 5th. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, so 3 to the 5th. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3, off the top of my head, 81 times 3, 243. So these are some perfect fifths. I stopped because I got bigger than the number that's underneath the radical. So 96 is not a perfect fifth, but what we can do is try to factor 96 so that is a perfect fifth times some other factor. So let's see if 32 will divide into 96. So 96 divided by 32 is 3. So we're going to rewrite 96 as 32 times 3, and the 5th root of 32 will be 2. So this is 3 times 2 and the 5th root of 3. And I just wanted to point out that I use the operation of multiplication here because when we write a number next to a radical, we assume multiplication. So we carry that operation down. So we have 2 times 3, which is 6. 6 times the 5th root of 3. All right, we have question 17. The directions say simplify 3 cube root of 27x squared completely in radical form. So since we have a cube root, let's write down some perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, so that's helpful. The number underneath the radical is a perfect cube. So we're going to be able to simplify cube root of 27. We carry that 3 down. We carry down the multiplication operation. The cube root of 27 is 3. And then we have cube root of this variable part. And when we simplify the variable part, we take the index, which is 3, and divide it into the power. And since 3 doesn't go into 2, we're going to leave this part of the expression inside the radical. So this will be cube root of x squared. We have 9 cube root of x squared. Here we have question 18. Simplify completely. 10 square root of 5 plus square root of 45. We have the operation of addition with radicals. When we add radicals together, we have to have like radicals. And like radicals have the same number underneath the radical and the same index. So we have a square root of 5 and a square root of 45. These are not like radicals. But we could try to simplify this radical, square root of 45, and maybe we'll be able to add after we simplify. So these are square roots. I know they're square roots because there's no index written. When there's no index written, we assume that index is a 2. So square roots means we'll write down some perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. And I'm going to stop here because I'm trying to simplify square root of 45, and I know that 9 divides into 45. So I'm going to rewrite the 45 as 9 times 5. 9 times 5 is 45. We have 10 square root of 10 square root of 5 plus, and square root of 9 is 3, and the 5 will stay inside the radical because it's not a perfect square and it couldn't be simplified. But now you can see that we have the same number underneath the radical. They're both the same index. We can combine these together. And when we combine them together, we do the math on the coefficient. So we're going to do 10 plus 3x, 10 square root of 5 plus 3 square root of 5. That's 13 square root of 5. So this is question 19. And with question 19, we want to combine the terms if possible, or enter D and E if they cannot be combined. We have negative 10 cube root of 135 plus 5 cube root of 320. And when we add radicals, we need the radicals to be like. Like means that they have the same number underneath the radical as well as the same index. So you can see that we do have the same index, but not the same number. So right now we can't combine these together. But we'll try to simplify these radicals. So these are both cube roots. Let's write down a few perfect cubes. We have 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So I'm going to try to divide some of these perfect cubes into the numbers that we have. So 135, let's see if that has a factor of 8. 135 divided by 8 does not divide. About 27. It does. So 135 is 27 times 5. So I'm going to be able to simplify cube root of 135 into 27 times 5. And then the cube root of 27 is 3, and we still have the cube root over the 5. Just want to point out that I did carry down the operation of multiplication. When we write a number next to a radical, multiplication is assumed, so I carried that down. So we have negative 30 cube root of 5. Okay, so I'm going to do the same thing with 320. I'm going to look for a perfect square factor of 320. Okay, so 320 divided by 8 does divide. 8 times 40 is 320, but when I look at 40, there's another perfect square factor inside of 40, 8 times 5. So I need to get a bigger perfect square. So let's divide 64. I jumped to 64 because 8 times 8 is 64. So 320 divided by 64 is 5. 64 times 5 is 320. So I'm going to factor 320 into 64 times 5. The cube root of 64 is 4. We're going to carry down that multiplication, and the 5 stays inside the cube root. So I carried down the operation of multiplication here. I have 20 cube root of 5. And now you can see that we have like radicals, and we're going to be able to combine these by doing the math on the coefficients. Negative 30 plus 20 is negative 10 cube root of 5. So question 20. Try to evaluate 10 to the 3/2 power without using a calculator. Enter D and E if the number is not real. So we have 100 to the 3/2 power, and we want to simplify this without a calculator. So we have to know what having a fractional exponent means. So let me show you in general. If you have a number to a fractional power, m over n, a to the m over n, having a fractional power is the same thing as a radical. So this denominator on that fraction is going to tell you the index on the radical. So we're going to have the nth root of a to the m. The number in the numerator is just a normal power. And there's a second way that you can write this because the order doesn't matter. You can do the nth root of a and then take that answer and raise it to the power. You'll get the same thing. So going back to our example, we're dealing with numbers. So I like to apply the radical first because it's going to make this number smaller. So I'm going to write this as 100, the square root of 100, because that 2 indicates we have a square root. And then I'll raise it to the 3rd power. The square root of 100 is 10, and 10 to the 3rd power is 1,000. So 100 to the 3/2 is 1,000.